Okay, so hello everyone. My name's Daniel Thoreau. I'm an engineer on the NNS team, and today I'll be demoing the SNS MVP. Before we get into the meat and potatoes of the demo, I just wanted to do a quick recap of what the SNS is and to go over what I will be demoing and what I won't be demoing today. So what is an SNS? An SNS is a collection of canisters responsible for decentralized governance of dApps. In that collection of canisters, we have the governance canister, which is responsible for neuron management, including staking and voting, as well as proposal submission and execution. There's also the ledger, which is separate from the ledger of the NNS and is responsible for the governance token. We also have the root, which is responsible for controllership. There will be one SNS per dApp, and there will be many SNSs living within the SNS subnet, which is a special segregated subnet securely made for the SNSs. So what will I be demoing today? As we are releasing the MVP and having our first set of partners start using it in the pilot program, we have a whole lot of features that we'd like to show. However, for the sake of the demo, I'll just be showing what the most important and different ones are from the NNS. So what I'll be showing today is SNS Quill, which is a command line tool for signing and sending messages to the SNS. I'll also be showing upgrade proposals, a very requested feature, so developers can continue to upgrade and develop their dApp in a decentralized way. And I'll be showing nervous system functions, which is the solution we came up to for developers to extend the SNS by writing secure governance gated functions that will automatically be executed after the proposal is adopted. There are many use cases for this, but I'll be demoing a small one for airdropping. However, as I said, there are many use cases. For instance, OpenChat is planning on doing large upgrades using this system. What I won't be demoing today is the actual initialization of an SNS. When I start showing my terminals, I'll already have an SNS running with account balances in the ledger for the dApp and the initial neuron. I'll only have a single neuron so that my proposals will automatically be voted on and executed. So you won't be able to see doing multi-neuron voting and following. However, this works very similar to the NNS. I also won't be showing motion proposals, as those are exactly the same as the NNS, and I won't be showing managed nervous system proposals, as those are very similar to the economic proposals for the NNS. So without further ado, let's get to the actual demo. Can everybody see my terminals fine? I'm going to take no answer as a good answer. So what's going on here? I've got a local replica running on the left side. In this local replica, I have a deployed SNS and a local dApp. I chose to run this demo with the encrypted notes-taking dApp, which is one of the examples that we created a couple months ago. Shout out to Arshavir, who on Monday helped me a great amount try and get this going. And as you can see, I have it running locally. So if I log in with the local internet identity provider, and if the demo gods shine brightly on me. Great. So it looks pretty much the same as a regular encrypted notes tab. I have, however, added a single UI element that we'll see change later. All this does is print out the version of the backend. So when we do our upgrade proposals, we'll be changing this. So with all that demonstrated, let's actually start looking at what we can do. So one of the most important things of the SNS is visibility. Users really need to be able to see what the status of an SNS is, given they'll be participating in various different governance of dApps with different levels of trust. It's very easy to trust the SNS or the NNS, but when you're trying to join a project, you're going to need to know about information of the dApp you're trying to join. So we have this command, which will actually show some status about this information. This is our root canister ID, and this is what it prints out. As you can see, in mainnet, this would print a lot of good information about the actual status of the canister. But most important for this demo, I just want to look at what the controllers are. So as we are a decentralized governance protocol, we need to know that the dApp is actually decentralized and still not owned by the initial developer. So as you can see, this API will print out information about the owned canisters. Here you can see the governance with its principal, and its controller is equivalent to the root canister ID. You can also see the same thing as for ledger, but most importantly, When we look at the DApp, you can see its principal and that its controller is only set to the root. Before this demo, I actually removed all the other controllers, so I shouldn't be able to fake this demo by just calling a DFX command in the background. So with that out of the way, I want to do a quick segue to talk about what SNS Quill is. For those of you unfamiliar with what Quill is, Quill was designed and developed during the genesis of IC, and it was meant to support cold storage wallet where you can manage your own identity. As this was very similar to what we wanted to support for the initial SNS pilot, we forked Quill as there are some different or some architectural differences. Mostly, as I said before, since we'll have many SNSs deployed to the SNS subnet, we can't determine which canister we're supposed to query as we don't know what their position in the subnet is. So we hard forked Quill and we created SNS Quill. It supports many commands and there'll be more supported in the future. And it works for both queries and update calls to the replica. For query calls, they'll be immediately routed because no identity is needed to sign those messages. But for update calls, since we support cold wallets, we have a two-phase approach. In the first phase, we'll sign the message, which you can sign in a cold storage wallet. And then in the second phase, you can send that message. For cold storage wallets, you would obviously transport it to a warm wallet. So now that we've covered that, I hope to show you guys a couple different commands throughout the demo, but let's actually get into looking at the SNS. So as I said before, visibility is very important to the SNS, so we've changed quite a few APIs from the NNS to increase visibility. One of these is that now you can list the entirety of all neurons registered within the SNS. As I said before, there's only a single neuron that we've registered just for the sake of the demo, and you can actually see the data printed out to console. This is very similar to the data of neurons that exist within the NNS. You have the ID, you have your cache neuron stake, which is what you've actually staked inside the neuron, what the fees are. This is where you would accumulate rejection costs. You have the created timestamp, what your typical followees are, what your maturity is, and your dissolve state. What's really different is our new permission model, where we've changed having just a single controller and multiple hotkeys to being able to specify any principal with a set number of permissions. So you can see neurons. What else is important to look at? Well, you can look at proposals. Obviously, this is a fresh start of the SNS, so we have no proposals in here, but I just wanted to demonstrate to everybody that when you're inspecting, you can actually see what is the current set of proposals that have both been submitted, executed, or failed. We'll be looking at these in greater detail later. Another thing you might want to look at that's different than the NNS is nervous system parameters. In the NNS, we had network economics, which was a set number of parameters that governed how the NNS would govern the actual economics. We've taken that a step farther in the SNS and introduced this idea of nervous system parameters. There are quite a few different nervous system parameters to allow for developers to have a more flexible way to program their SNS. For instance, you can adjust reject cost, neuron minimum stake, transaction fees, and a whole lot of different other ones. One of the new interesting ones is the new permission model where we have a claimer permission and a grantor permission. All of these just allow the SNS developers and people who want to deploy them to tweak it to their use case. For instance, you can imagine a case where an SNS developer wants people to stake quite a bit of tokens, so they have a higher minimum stake requirement, or a place where they just want everybody to be able to vote who has an internet identity, and therefore they'll set the stake to 0. So before we move on to actually submitting proposals, I want to look at some state of the ledger. The ledger has a few accounts already credited with some END token, which is the native token I created for this encrypted notes DApp. You can see here, this is the account ID of the DApp we have deployed. You'll actually see later this DApp airdrop some of these tokens. So its account balance is set to 100 END. And eventually, we'll see it credited to an account, and the starting balance of that account is 100 END tokens as well. Great. So now we've actually seen how you can examine an SNS and what different internal states you can look at. Let's actually try and do a proposal. So one of the most important proposals that we have is the upgrade proposal. For developers to be able to continually develop and enhance their DApp, they still need to be able to do upgrades. But since this DApp is now decentralized and they've lost their initial controllership, we need to provide a way for them to issue proposals that will have the proposed update. It works in the very similar manner as how we update governance and ledger inside of the NNS subnet. And to do that, I'm going to demonstrate by changing the WASM of the encrypted notes DApp. So this is pretty much the same, but I've introduced a couple methods. We'll go over the other two in a second. But as I said before, in the encrypted notes DApp, I have a hard-coded version that I return that the UI element will display. As we saw before, it was set to v1.0.0. So all I'm going to do is just increment this here and try and upgrade the WASM to reflect that. So if I am in the correct directory where I can build this WASM, I'm going to cross my fingers that Rust doesn't take forever to compile, and we're just going to change that there. This will create a new WASM that we can copy to a very convenient location inside of my SNS quill directory. As you can see here, we have the encrypted notes WASM, and all I have to do is use this single SNS quill command to submit it. To go over some of these parameters to the SNS quill, as I said, there are some architecture differences to the regular quill. For instance, we need to be able to specify exactly which SNS cluster you're talking to, which is represented by this file. As there are identities that you need to have be able to have the permission to submit proposals for a neuron, you have to provide that identity file. You'll also provide the subcommand, make upgrade canister proposal, the neuron ID of which you want to submit this with, other metadata such as title and URL, and the target canister and encrypted and path to the WASM. As this is an upgrade, there's actually quite a large message, so I'm going to pipe this into a message.json and not display it. This is because we, in the proposal, will send the entire WASM, and that is 1 or 1.5 megabytes for this app, and I don't want to make this screen scroll forever. So I'll be demonstrating this in a little bit more detail later, but for now, I'm just going to pipe the output to dev null to save everybody's eyes early morning. So what I want to be showing on the left side is the actual replica code. As you can see, since I said I was the majority neuron, my proposals will automatically go through as I have the majority stake in Liquid Democracy will just automatically accept this proposal. You can see in the logs that the managed neuron, which is what API is invoked when you submit a proposal, has printed, and the actual proposal has executed and succeeded. So let's actually look at what that proposal looks like now that we have one in the SNS. So if you see this, we print out all the information when you list it. You can see the actual ID, the neuron who submitted it, what the reject cost would have been, the proposal information, some of the tally, and since this successfully executed, you can see what its decided timestamp is and what its executed timestamp is. Additionally, what's different from the NNS is we now have payload text rendering. This will become more important in the next part of the demo, but as you can see here, we've rendered a very nice message that says that we've tried to upgrade this exact canister with this SHA, with this WASM, but showing it as SHA 256. Great, so I've now updated the canister. We should now see that the version has been upgraded to v1.0.1. So I've shown that these proposals should theoretically be able to upgrade through a decentralized way. And I'll be able to move on to the next part of the demo. So as I said before in the slide, I'm going to show the next part, which is the nervous system functions. This is a very requested feature and very important as we need a way to develop on top of the SNS in a secure fashion, but we can't exactly imagine every single possible function or proposal type that devs are going to need to manage their DApp. So we designed a solution called the nervous system functions, where you can write very generic functions on canisters and save the metadata inside of the SNS. This metadata can then be used to look up with the function ID and pass a payload to execute. So that was a whole lot of words. Let's see what that actually looks like in action. So what does a nervous system function look like? Well, when you register it inside of the SNS, you first have to add it and go through regular governance proposal and voting so that the community can agree that this is a worthwhile function to add for your SNS. What this will look like is you'll submit a proposal, same as normal, but this time you'll have an action of add nervous system function. You'll specify an ID that people will use later when trying to execute. The actual target of the canister, this can live anywhere, but for the sake of this demo, I've actually added this to the DApp. You'll specify what the method name is. In this case, it's airdrop, and you'll specify some validator information. This validator information is necessary because the SNS at runtime won't know any information about the payload you're providing, and there'll be some way for users who are participating in governance to examine the payload and make sure it's doing what the submitter actually says it's doing. So if we examine the code, I've written a very simple method called airdrop on the encrypted notes tab, which will take a series of, or not a series, a single airdropee account ID and give it one END token. It'll call the ledger and transfer from the DApp's own treasury. As far as the validation goes, all I do is I take the arguments and print a nice message where I decode and print which account ID is actually being airdropped to. So now that we've seen what that'll look like, let's actually try and register this. So with another single SNS quill command, we'll be able to register this nervous system function. Again, you can see the SNS quill in action. Since this is an update message, we'll sign the message, and when you try and send it, it'll ask you if you want to proceed. You can see that the proposal again was submitted, whoops, out of there, and executed. Now that the proposal has actually been executed, let's see if we can list this. Again, visibility into the SNS is one of the most important things, so we've included an API where you can list all the nervous system functions, and you can see all of our information is there. Now that the metadata is captured, anybody can come in and try and execute one of these functions with a particular payload. Now, what might that look like? If I look at one of these proposals, you can see it's the same as any other proposal with a title, summary, and URL, but this time I have an action of execute nervous system function. In this case, I'll specify what the ID is, the one that I provided in the metadata, and then I'll pass a candid encoded payload. This, of course, is not known how to decode at runtime and why we have the validate method. So let's see if I can actually send this and execute an airdrop to the principal ID of the most participating neuron that we have. Again, SNS quill will sign the message and ask if I want to send it. I do. And you can see it succeeded. And on the left side, I've airdropped one END token to this account ID. That's great. Let's make sure we can actually look at this proposal and that it executed. Everything looks good here. Oh, sorry, I'm looking at the wrong one. You can see that it executed here. And at runtime, we actually called that validate method to validate it and render it for the eventual SNS front end. As you can see here, it decoded the candid payload and formatted it nicely as I demonstrated before. So it looks like the proposal executed. Let's see if we can look at the account balance of the DApp and make sure that it actually was decremented. Everything looks good.
Sorry, your time is actually up, so maximum 1 minute left.
Perfect. I have less than 1 minute to go. So you can see treasury decremented, and if we look at the principal, the account of the neuron holder, it was increased. So we were able to reward our very active participant in the community, and we were able to do it via nervous system functions. That's all I'll be demonstrating today. Feel free to ask any questions. I know I'm late on time, so you can either message me directly or drop something in the chat. Thank you all.
Thanks, Daniel. This was
Daniel.
great demo.